Alrighty, and on to page 2 of dilations. Alright, so if we look at the distance from the center of dilation to the points, those numbers will give us our scale factor. So that'll tell us how much we enlarged by or how much we shrunk by. And you always want to look at the P prime because that tells you if it's an enlargement or a reduction. So like in this case, that's P, and then there's P prime, and this is the smaller shape. So in example 1, we have a reduction, and for a reduction, your scale factor is always less than 1. For an enlargement, your scale factor is always greater than 1. So for example 1, we have the two distances, C to P prime is 5, and C to P is 10. Since it's a reduction, we want a fraction, so 5 over 10 is 1/2. So for example 2, we have C to P is 7, and C to P prime is 15, and this time the P prime is the larger shape, so this is an enlargement, which means we need a number bigger than 1. So this time I'm going to put the 15 in the numerator, so my scale factor is 15 over 7. Okay. For example 3, the sides of the shapes can also give you the scale factor. So in this case, because the P prime is attached to the smaller shape, we know it's a reduction. So our scale factor is going to be 5 over 12. And anytime you multiply by the scale factor, because remember back to page 1, that's how we found the new shape, is by multiplying by the scale factor, you can find the missing sides. So if the original side is 6, then the image is going to be x equals the scale factor times 6, which ends up giving us 5/2. Example 4, well, I have this side is 12 and this side is 4, and the P prime is larger than the original shape, so this is an enlargement, so I have to do the 12 on top, so 12 over 4 says our scale factor is 3. The new shape is 3 times as large as the old shape. So now to solve for x and y, we just take the original numbers, 5 and 6, and multiply by our scale factor. So x, 5 times 3 is 15, y, 6 times 3 is 18. Alright, so next we're going to look at dilation specifically in the coordinate plane. We are just focusing on right now that the origin is our center of dilation. And this is much, much easier because all you have to do is multiply everything by the scale factor. So for example 1, scale factor of 2, I find my original 3 coordinates, 0, 3, 2, 4, and 4, 0. I multiply them all by 2, and so we get the new coordinates 0, 6, 4, 8, and 8, 0. And it went off our graph a little bit. No biggie. Alright, so example 2, our scale factor is 1/3. But please be careful. Notice it went by 2's on this one. So be careful when we say what the original points are. The original points are 5, 7, 9, 3, and 3, 1. And I multiply each of those points by our scale factor of 1/3. So I get the new points, 5/3, 7/3, 3, 1, 1, 1/3. And we just have to approximate where they're going to go. You know, it can't be perfectly exact because we're going by 2's and we have fractions, and we just do our best to draw it accurately. And example 3, our scale factor is 3/2 or 1 1/2. So I got my 4 original points, -1, -1, -4, 2, -1, 4, and 2, 1. Okay. And I multiply each of those by our scale factor of 3/2. So we get the new points, -3/2, -3/2, -6, 3, -3/2, 6, and 3 3/2. And we have our new shape right there. All right, so that takes care of our notes for day 1. Love you all, miss you all, bye.